Hello everybody and welcome to day 2 of the Edyst June 2021 daily challenges. I have 3 special things for all of you. Number 1, who's actually won the prize today. Number 2, a special announcement about our algorithms and data structures batch. And number 3, an actual solution of today's daily challenge. So let's actually get started. So this is the June 2021 daily challenge that we're conducting from the 8th June and today is 9th June, today is Wednesday. What we're basically doing is every day from 8th till 11th June, every day we're releasing a challenge at 11 a.m. So you can log in on the link in the description below. If you crack the challenge, you will be on top of the leaderboard and we will announce the prize on the same day itself. What are the prizes, you may ask? Well, we have one daily winner. So I'll announce who the daily winner is for today. There's also a random participant who gets a prize. So just for participating also, you can get a prize just for being online and participating. And we have those 2 prizes ready for today. So who's won the challenge today? That's on day number 2. Who's actually won it? So today, give a round of applause for Chitresh again. So Chitresh won it on day 1. He's also won it on day 2. First to crack it on day 2. You're doing a great job, Chitresh, for cracking these challenges. They are not super difficult, but your speed is really amazing to crack that. And the one random winner for today, just for participating, is Tulsi. She gets a JBL headphone, and Chitresh ends up winning a Boat Stone speaker. So day 2 prize was Boat Stone speaker. Tomorrow's prize is going to be an MI band, and day after's prize is going to be an Amazon Echo Dot. So please, everybody, participate well. You too could win something, right? So participate well, and you also can end up winning something as well. Okay, now before I go ahead to the actual solution of the challenge, let me just talk to you a little bit about an upcoming data structures and algorithms batch that you should all check out. This is the Edyst June 2021 batch of algos and data structure. It starts on 19th June. We have only very limited seats, and if you want to sign up, you can just check out the link in the description below. Being conducted by 2 instructors over here, that's me and Devang. We're going to just interview Devang sometime soon, so you can hear directly from him. But he has cracked Microsoft, Google, PayPal, and a bunch of other product-based companies. He's currently working at Cisco. He's cracked more than 30 product-based companies as far as I remember, and it's just insane. So, if you want to learn from the best, then this is really the right place to come for. And we have this Algos Data Structures bootcamp going. It's just about like a 2.5 months bootcamp. So if you are someone who's preparing for placements, who's not sure about their Algos Data Structures skills, do check out the link in the description below to know more about this batch. And you can also reach out to us on the number given below. You can WhatsApp us. We'll give you all of the details as well about this. All right, cool. You might be wondering, has someone actually taken this bootcamp earlier, and are we, or are we just doing it the first time? No, we've been doing this for a long time, and our alumni are working in companies like these, all product-based companies. They're working, the minimum package being somewhere like 8 to 10 lakhs per annum, maximum going. We just got news today that somebody got placed at 45 lakhs per annum. That's right, 45 lakhs per annum through the same bootcamp. So if you do want to get those kind of packages and aim for those level of packages, it's a really high time that you can join a bootcamp like this. All right, so having said that, let's actually go and check out the question for today, which is called Plato and plants. So let me just check that up, and let me just open that and get the question over here. So the question is over here as follows. All right, so this one is a little lengthier question, so I'll tell you the logic, and the code for the same will be uploaded on the Edyst platform pretty soon, so you can also check out that soon enough. So just give me 1 second. I'm just opening it up, and here we go. All right, 1 second. Yeah, it's still loading. Just give me 1 second over here. Yeah, there you go. So this was challenge number 2. Let's open challenge number 2. A lot of you were able to solve it, great, but you have to solve it really quickly also. So you have to be the first one to solve it. If you solve it, then you get the prize. All right, so there are n plants on the number line. Okay, and the position on the number line is numbered as 1, 2 all the way till infinity. The ith plant is assigned to look after the range Li, Ri on the number line, which means that it will watch all the positions from Li to Ri inclusive. So from left to right, it's going to watch all of the positions. the length of a range is defined as the number of integers. So for example, if I give you the range 1, 3, it's not just 1 and 3, it's not two elements, it's not even like, you'd say 3 minus 1, no, it's 3 minus 1 plus 1, because you're counting 1 also. So 1, 2, 3, 3 elements are there. Similarly, 10 and 10 is not 0 elements, but rather one element that the plant is looking after. For instance, if one of the plant looks after 1, 5, another plant is looking after 3, 10, then both of them look after 3, 5. So now we're talking about intersections. You have one plant looking after 1, 5, another plant looking after 3, 10, then you're talking about the intersection, which is 3, 5. Or in other words, I'll just take an example over here for you. Let's say you have the range 1, 6, and the next range that you have is 2, 6. Then both the first, let's call this as, let's say one second. Yeah. So if I were to call this as P1, this being the first plant, and taking all the way here, so both P1 and P2 over here are looking after which plants? So this is looking from 1 to 6, this is looking from 2 to 6. So collectively they are looking at it from 2 to 6. That is the overlap they have is from 2 to 6. Or if I were to take these plants, right? So P1 to P3 over here, P1 is looking from 1 to 4, P2 is looking from 2 to 5, and P3 is looking from 6 to 7. So in this case, if I have to check between P1 and P2, the collectively what they're looking at is 2, 3, and 4. And if I have to check P1, P2, and P3 all together, then they're not looking after any common range because there is no overlap. While these two overlap at this point, 6 and 7 is not overlapping with anything from the previous ranges. Or if, let's take another example over here. Let me just take up another example for you. Let me take another example here. So let's say, for instance, if we had not like this, something of this sort. So let's say if you had, right? So in this case, P1 is looking after 1 to 4, P2 is looking after 2 to 5, and P3 is looking after 4 to 7. So the one that overlaps among all three is just 4. So there's only one element being looked after, or one plant being looked after by all three of them. You might say, sir, why not 5? Because 5 is being looked after only P2 and P3, P1 is not involved. What about 3? P1 and P2 is involved, P3 is not involved in that. So hence we are looking after that. So if you understood this, that how the ranges are being looked after, now let's look at the question. The question says your task is to eliminate exactly one element and then find the length of the longest range that is covered by all the other n-1 plants. So the question says that you have to remove one range. It's like you have to end up removing one range for sure. Okay, you cannot not remove one range. You have to remove the one range. But the choice is left up to you that which range you're supposed to remove, such that removing that range will give us a very long coverage, long common coverage for the other plants. Okay, coming back over here, for example, I could technically remove, let's say, P2. So let's actually try to remove P2 and see what happens. So if I do remove P2 over here, what will happen is P1 and P3 have an overlap of just one element. Or if I would remove P3 altogether, okay, then P1 and P2 have an overlap of 3 elements, right? Now you say, sir, earlier also that an overlap of 3. No, you have to get the overlap of all of the plants existing right now. Earlier P3 existed, so we could not take this overlap. Now that we remove P3, we can actually take this overlap, which is of 3 elements. Okay, what else? Can I remove P1 altogether? Yeah, you could try to remove P1. If I remove P1, then P2 and P3 do have an overlap, but that overlap is of just 2 elements. So our idea is we need to get that overlap, which is the longest overlap possible. Okay, and hence in this case we will actually remove P3. Now to us humans, it's actually quite intuitive to figure out which one to remove, right? So for example, if I look at this, here I have not only P1, P2, P3, I have actually P4. Excuse me, right? So for instance, I could remove, let's say, P2, but in that case I'm left only with P1 and P3 overlap. P4 will not overlap, and which will give me 0 overlap. As it is right now, I have a 0 overlap. As it is, I have a 0 overlap because there is no cell in which, or no column in which, or no plant which is looking after, or basically no number which is being looked after by all of them, right? So I don't have anything like that right now. All right. So if you look at, in this case, P2 and P3 are not available. In this case, P3 and P4 are not available. In this case, P2 and P4 are not available. So I have to remove one of them in any case. Which one do I remove? in this case, no matter what I remove, I will still not get an overlap. So for example, let's say I end up removing, let's say I take this, I end up removing P4. I don't have any overlap between P1, P2 and P3. 7 was the closest shot, but again P2 doesn't come in over there. Okay, what about over here? Again, no overlap if I remove this, because P1 and P4 overlap, but P3 is not involved. So in this case, the earlier overlap was 0 and my new overlap is also 0. My answer will be 0. Even if I remove one plant, which I have to remove, I will still not be able to have an overlap. Okay, all right. What about in, let's take the first case itself. In this case, I have an overlap of, if I take all P1 to P4 together, I have an overlap of just one range. However, if I remove one of them, so let's say I remove actually this one, okay, then I get an overlap still of one element only. However, if I remove this one, I get an element or overlap of two elements. So the answer in this kind of a case would be 2, because I can actually get an overlap properly over here. Right, I'll actually get an overlap. So the answer will be 2. That's the longest range. Remove P4 and the longest range you'll get. Now the question does not say which range to remove, so you can be happy about that. I don't really need to remove I don't need to tell which range to remove. All it's saying is after removing, what's the longest range that's there. Now this question comes with a couple of observations. So if you know how to make your observations, then you can actually crack this question really simply. What are the observations that you have to make? First things first is, even just looking at it, so I'll actually look at the constraints as well. All right, so if I go to the constraints, you will notice that over here, so go to the constraints, n is up to 10 raised to 5, okay, and L and R are up to 10 raised to 9, which basically means that the value itself, the range itself, can go pretty high. So one of the examples you might have thought is to just generate a big range and just figure out where the overlaps are happening. The problem with that is 10 raised to 9 is very big, and you can't generate an array of size 10 raised to 9. Most of your languages will not allow that. The second issue that you're going to face in this is, how do I just figure out what's the overlap? You can't really you can't go through the array multiple times, because it's 10 raised to 5 over here. That will cost you a lot to go to the arrays multiple times. It's almost 10 raised to 6. So, you have to do something in n or n log n time over here. That's what you'll actually need to do. Why is that the case? Why do we not do n square and so on? That's a little bit out of scope here, but bottom line is you can do 10 raised to 6 computations, and if you do n square, you'll go to 10 raised to 10. So you can't. Why can you do 10 raised to 6? Because most compilers will allow you that much time. Hence, by looking at the constraints, you can figure out what is the order of your approach going to be. Now, if you want to learn this more in detail, do join our data structures algorithms batch coming up, hosted by me and Devang. Please do check that out. But anyways, coming back on this one. So what we're going to do is, we are going to figure out how, even before removing, what's the biggest overlap that I can get. And this is the first observation. Now, I will tell you all this, that if you are someone who's still trying to figure out the problem, pause this video right now and think about it yourself. But the first challenge that comes to you is how to figure out the longest common range even without elimination. Okay, so even without the elimination, how to figure out the longest common range, or just the common range. Forget the longest. Common range means all n elements have to be there, right? And the way you can actually figure this out is to think of what is it that's going to limit you the most. Okay, so again, those of you who want to figure out yourself, do pause the video right now. But the others who just want to, as another YouTuber says, if you just want to enjoy the show, this is how you do it. Okay, now think about this. In this kind of scenario, which is the one that limits the entire common range? It's the one that starts the latest. All of them are ending at the same time, but the one that starts the latest is the one that's limiting my range of commonality. Okay, what about, let's say, something like this? Okay, here also the one that starts the latest is limiting my common, and the one that ends the earliest. So if you think about a range, right, what's going to happen is every range is going to try to span as much as possible, but the one that starts the latest and the one that ends the earliest are the ones that are going to dictate where it is that we have stopped. Okay, or what is it that's the common. So for example, here the one that started the latest was P3, the one that ended the earliest was P1. So both of these will tell you how much is your commonality. If the one that starts latest is beyond the one that ended the earliest. So for example here, let's say something like this, the one that starts latest is this P3, the one that ended the earliest was P1. No matter how many more ranges you do, you will never have an overlap of all the n plants. It's not possible, okay? Because you have one range ending before another range starting. So in order to even have an overlap, you need to have all of the starting points before the ending points. If any one starting point is after a previous ending point, you will not have overlap of all n elements. You'll still have an overlap, like P1 and P2 are overlapping, but you will not have an overlap of all the P1, P2, P3. Okay. If you didn't get this, pause it right now, rewind and check again what I just said. Okay. But the first observation is this, that the only way I can get an overlap is if my starting point of any range is lesser than the ending point of the earliest range to end, because the earliest range to end is the one that's going to always cause me the trouble. Okay. If my starting point is greater than that, I'm not going to have any overlap. So that's the first thing. So number one, to find overlap, okay, it's going to be max L, that's the latest starting range. So this is max L meaning the maximum L part of this, okay, L of a range, and min R, the one that ends earliest. So common is going to be min R minus max L, and if this happens to be negative, that means that R ended before L started. That means that if common less than 0, then common is equal to 0. What that means is that there is no common part, because you can't have a negative overlap, right? So you'll say that if common is less than 0, then common has to be equal to 0. And over here, just one small thing, min R minus max L plus 1, because let's say both end and start at the same point, we are not going to cancel them off. Like 10 is not actually 0, it's 1, right? So same thing over here, we are not actually going to cancel them off, we'll add a 1 over there. Okay, so min R minus max L plus 1. All right, so that's what we have here to find the overlap. Now this is to find the overlap of n elements. How do I find the overlap of, or how do I know which size to eliminate or which range to eliminate? How do I know that? Well, again, the trick lies in this. The one that is causing us the most harm, okay, so our candidates to remove are the one with, let's say the first candidate is the one with min R. This is the one that's ending earliest. If you remove this, probably you can get another one which is ending a little bit later, right? So you will get more overlap in that case. So you remove the one with the min R, removing that will help you get a bigger overlap. Or you remove the let's not say the one, range with min R, and let's say range with max L. Okay, let's look at this in action over here. Okay, what this means is over here, okay, this is the one that's ending first and this is the one that's starting at the end. Either you remove P1 or you remove P3. Either one of them will help you out, because both of them are the ones that are causing us a problem. By definition, P3 is the one with max L. Anything else you choose will start earlier, thus giving us more overlap. Okay, or by definition, P1 is the one that ends earliest. That means that if you take another element apart from this one, then it will end later. Why? Because P1 is the one that's ending earliest. It's min R. Anything else apart from that is going to have a greater end point. Okay, so P2 and P3 both are going to have a greater end point than P1, because P1 was the minimum one. Anything else you choose has to be the maximum. Let's look at, for example, this one over here. The min R over here will be P4. Max L over here is going to be P3. You have to remove either one of them. Even after you remove, you may still have an issue. I'm not saying that. Even after you remove, you still have an issue. Could have an issue. Okay, but even with you remove, like the candidates are one of these. After you remove, you still find zero overlap. That's also fine. There's no issue in that. But the candidates to remove are one of these. So what you're going to do is, in this kind of a case, you are going to choose which. You're not going to choose. You're going to try both of them. You'll say, okay, remove this. So take, what you could do is you could do candidates to remove are number one, range with min r, range with max l. So what you'll do is remove first candidate and check new overlap, remove, and then undo this move. So either we remove the first candidate or we remove the second candidate. You can't remove two, you have to have n minus 1 elements, right? Okay, add first candidate, remove second candidate, and check new overlap. And remember everybody, overlap, you don't have to go through the array again. Simple way of overlap is just this, min r minus max l plus 1. So what this means is, if you remove the range with min r, then you have to go to the second min r and find out the new overlap. If you remove the range with max l, find the second max l and find the new overlap. That's what you're going to do. Okay, so how does this work? Well, what you're going to very quickly do is that you don't care about the first common. What you're just going to do is find first candidate, pair with min r, find second candidate, pair with max l. After you've done this, number one, remove first candidate, find pair with min r, find pair with max l, calculate new overlap. Okay, so let's call this overlap 1. Okay, second thing what you're going to do is find this, remove the second candidate. So then what you'll do is add the first candidate back, add first candidate back. Then you'll do is add first candidate, remove second candidate. Okay, and what you'll do is find pair with min r, find pair with max l, and calculate new overlap. This overlap will be, let's say, overlap 2. Your answer will be whichever gives you the more overlap. Answer is equal to max of overlap 1 comma overlap 2. That's your answer over here. Now, how do you actually go and implement it? We are going to upload the solution on the Edyst platform, so you can check it out for a detailed solution. Most of you requested it in different languages, so we'll be uploading one in Python, C++, and Java. Don't worry about that. Till that time, try to figure out how to solve this one. All of these can be done in order n time. Finding the minimum r, pair with minimum r, you can find an order n. Finding the pair with max l, you can find an order n. Remove it, then again find the pair with minimum r, max l, again order n. Remove second candidate, add the first one, again find minimum r, max l, you can again find an order n time, it's fine. You could also sort it if you wanted to, that's n log n, and with this n equal to 10 raised to 5, sorting is also fine. So n log n will also be okay with you. So any of those approaches is okay, as long as you've got this observation, then that will be fine for you to do. Okay, so that's the question, Plato and plants. Do check out the solution on the Edyst platform. We'll be sharing it shortly, and yeah, do try this code out. Hope you are liking the level of questions. If yes, please let us know in the comments, and please do let us know any other thing you'd like to know in the comments. Don't forget to subscribe to this channel. This is not the only challenge we'll be running. We'll be running some amazing challenges going forward, so make sure you subscribe to this channel. And yes, everybody, do sign up for this algos and data structures bootcamp that's launching pretty soon. We are not taking everybody in. It's a limited set of seats only, so do join as soon as you can. Already a few seats have been taken, so you can check out the link in the description below for this one. All right, gear up for challenge number 3, and wishing you all the best. Hopefully someone different wins it, but if not, if Chitresh wins it again, happy to give him another prize. All right, okay, thank you so much everybody, and I'll catch you all next time. Thank you so much.